All right. So again, the directions here that say simplify by switching to sines and cosines, and then use the property of fractions in order to simplify this is hugely important. Again, I saw the cotangent thing and I tried using a conjugate, like I tried changing things up, and that did not work well, so I would not suggest that. So they're telling us to switch into sines and cosines, so that's what we're going to do. We're going to follow the directions.
That surprised me. Wow.
What is that laugh? Like, were you wheezing?
Who's the wheezing one?
I don't know.
Okay.
Yeah, what did you
Drawing out of breath.
I'd like to know.
So
Walking.
one of the things I want to point out is with fractions, you have to be really careful with canceling and addition. So like if I see addition signs, that's kind of a clue to me that don't just start canceling because I see like cosine, sine, cosine, cosine. I can't just cancel that all out. So just be careful when you have addition and fractions. So going back to like our homework from a couple days ago, so the one where you had to add, subtract, multiply, and divide fractions, I believe this was like on the bottom middle, I can picture it on the worksheet, where we had an addition problem divided by an addition problem. If you recall, what we did was we simplified the top and then simplified the bottom. So those kind of have to stay as a unit until I have it simplified. So that's what we're going to do next. So kind of thinking about fractions and what I would do. So again, if it helps to think about this as 1 plus 5 over 4 over 1 plus 4 over 5. Like what would you do in this case? Now just use that same idea. Looks like I don't know what to do there either. So change that to, he was only making very large gestures, so that's why I called him out on that. But the sine and cosine, same idea. So if I want to add a whole number to a fraction, what do I need to do with the 1? Make it a fraction. How can I make 1 into a fraction that would help me for adding it to sine over cosine?
Oh, sine.
1 over 1.
No, sine squared. No, I don't know.
Yeah.
Cosine over cosine?
Yeah, because this one already has that cosine as a denominator. So cosine over cosine is the same thing as 1, right? Something over itself just equals 1. The reason he chose cosine over cosine is because that's already the other one's denominator.
He's a genius.
He's a genius.
What if you did sine?
What's that?
What if you did sine?
Then you would have had to get common denominators, so that would have been
No
painful.
fun.
But we chose something, so that like down here, I would have done this 4 over 4 plus 5 over 4. So I would have been smart about my denominator and about, okay?
Schmeat. What would
All right. Now, before Owen tells you what to do,
On what we do.
no, don't,
I don't
Owen,
know.
don't tell him.
Exactly.
he knows.
He always smart.
Okay,
Sometimes
down
he
here,
knows.
we're gonna be smart, like Owen, we're gonna be smart. We're gonna change this. Okay. Brain steroids?
Yeah.
Would you ever get a Botox? No.
I don't know, like,
I
just like feel like
water.
sometimes it's like something that,
I don't know, I think wrinkles aren't, it's just part of life, I don't know, like, I don't know. And then if someone compliments you, you're like, you look really good for your age, you're like, oh, Botox. Like, I mean,
Yeah.
like I wanna look good for my age because I take care of myself, not because I pay to get an injection. I
what
don't
if somebody
know.
offered it for free, would you still say no?
I don't know.
The more wrinkles you have, the wiser
Probably.
you are.
I don't know.
Mr. Stan.
What?
Sure.
I have good genes too. Both my parents, I feel like, don't have, like,
I'm not afraid I'm
Alright.
going to get you.
All right.
Class would really be right there.
Okay, so guys, now that we have these common denominators, now I can just add the tops. Now, obviously we can't do much with them because they're not like terms. you see sine and cosine being added together, they do not equal 1 because they're not squared. So be careful, that's not a Pythagorean identity. So I'm trying to point that out not to confuse you, but just to make sure you realize that you can't call that 1. Now when we're dividing fractions, and we have a fraction within a fraction, we're going to multiply by the reciprocal. So now we can flip this. So we're going to flip this bottom one and multiply. So the top one's going to stay as it is. The bottom one's going to flip and multiply. Yeah. Now, since we have the same thing on the top and the bottom, and they're exactly the same, now we can do some canceling because that whole thing cancels. It's not just like part of the plus sign cancels. Okay. Now, sine over cosine is a fine answer. Can we write that as 1? Yeah. Either one is fine with me. Like if I'd probably prefer 1, but I'm fine with this. Gross. What's that? It's a lot of work. It's even more work when you go the wrong way to start. So mine's like way crazy.
Even if you accidentally add this sign inside of it, you know, and it's still the same.
Oh, that's kind of crazy that that works.
Because that's what I did when I was thinking.
Oh yeah, it would work.
But not in every situation.
And like, if you're trying to show your steps, like if I was taking like verify that it works, yeah, I could give you full credit, but yeah, no, All right. Okay guys, this is another one where it gives us what we're going to. So this is what we're starting with. This is what I want to end up with. But again, they give you a little clue here. They say to use those conjugates and trying to simplify. Now this is what I was trying to do with the one above. I was trying to do a conjugate there. And like I said, I'll try to give you guys little clues like this tonight for your homework. So conjugate is just the opposite version of this, of that bottom one. So I'm going to multiply by 1 plus the sine of x, because they told me to. They gave me that clue. If I do that to the bottom, I have to do the same thing to the top. Now the bottom I know is a conjugate, so I know it's going to work out very nicely. Those middle two terms are going to cancel. I'm going to end up with 1 minus sine squared. The more you do this, the more you're going to recognize, I see 1 minus sine squared and I immediately think what it's going to be next. Like you're kind of constantly thinking about where we're headed with these. But it just takes practice. I'm going to distribute this in. I don't actually think I have to. You can do it a number, like either way, but I distributed it in, so I'll show you guys that way. All right, what do you notice about, like I said, the 1 minus sine squared? I hope you like that jumps out at you now. What do you know that equals? Sine squared. See, like, so that's something that, you know, yesterday you didn't know that when you walked into the class, but today it's starting to become a little more automatic, hopefully. I asked asked Mr. Donahue on my way down here if he would come teach my class for me, and I could take a nap in his classroom instead. And he's like, oh yeah, you're teaching about numbers. I can come. And I was like, oh no, there's no numbers. And he was like, never mind. So like, I'll help with numbers. I realize now that probably distributing that in probably was kind of a little bit of a waste of time there. But does anyone see?
Why do people like mathematicians mix numbers with letters?
Yeah. What others? Okay. So, if you guys ever stuck on something, I would suggest trying to write it with variables. So like in this case, I called cosine x and sine y. So I called this x plus xy, cosine plus cosine sine over x squared. You guys should know how to solve this.
Oh wait, you can.
Or simplify, right? What can we do?
This is one where you could cross out the cosine x because the bottom is squared, so you can use that as well, right?
Close. I don't think exactly what you said is correct. So there's an x in each spot and there's an x squared in the bottom. How can I simplify this? If you were to simplify the algebra up there. Yeah, you can get rid of a cosine out of like kind of all three parts, but only, I don't know if this is kind of what you were saying, but only one of them is lost down here because basically it's like I'm taking an x out, and I'll be left with 1 plus y. And I look at that x over x squared, there'd be 1x left on the bottom. So again, I don't know if it makes more sense to factor this.
It makes sense because I didn't distribute.
Oh.
That's
Oh, okay, yeah. And so actually, like I said, now looking back, I actually think it might have been smart to leave it this way, but, you know, without knowing too much ahead of time. So what I'm saying we can do is that, so I factored this out now. So I took a cosine out, just like I factored out the x down here. One of these cosines is going to cancel with one of those. Okay, so you guys, this is cosine, and then this is cosine times sine. So I took a cosine out of here. I factored it out. Just like I would factor out an x here.
That's where you get the 1 plus.
She factored it
Because
out.
I factored it. So again, if this is like x plus xy, I take out an x divided by x is going to be 1.
Oh.
X divided here is going to be y. So I'm left with, I take out a cosine divided by cosine is just 1.
Gotcha.
Divide the cosine out, I'm just left with sine. And I know it's weird to see it written this way, because yeah, we've never factored with cosine and sine before. I know that. We're learning. I mean, again, this is not something you guys came in knowing. So we're left with 1 plus sine x on top over cosine of x. Now this is one that it told me what I wanted my answer to be. Any thoughts on how I can go from there to there? This is kind of a weird step because I wouldn't think to do this unless someone asked me to do this. I feel like that might just make it more complicated, but it's not. You're not far off from where you want to do. Yeah,
I don't know how
I describe it.
this.
Yeah, that's kind of. I'm going to go one step a little bit slower than you. So, just like we, when we combine combine fractions, let's take these apart. If this was being added, it's 1 over cosine, right? Plus what over what? Sine over cosine, right? So this step is a weird one because I just wouldn't think to do this unless I was trying to, you probably wouldn't do this with normal numbers. Do you guys agree that this is the same as that? It's just, it's just the same common denominator. it just, why we can break it up is they both have the same denominator, so I can just give them each that denominator. And 1 plus sine would go on top. And now, 1 over cosine is secant. Sine over cosine is tangent. Whoops, that's really ugly. Tangent. Okay. All right. How about, I want to make sure we have enough time that you guys have time to get started on this. I think I'm going to stop for right now. If you worked ahead, awesome. Like, we'll talk about those at some point here. What I want to do though with you guys is maybe give you a clue on how to get started on some of the homework. Would that be like kind of like I did in some of these, like what I like switch to sine and cosine right away, kind of those kind of steps. I think that might be good for the homework just to kind of give you a heads up on what to do. So I'm going to pass out the homework and then I just ask you guys to kind of follow along with us and we'll kind of give you some clues here. And I will warn you that I think number 1 is one of the tougher ones. So don't get yourself like all flustered and give up after number 1.
The whole bunch of these.
That's what we do.
What?
You're done.
Huh?
Your pointer finger goes up.
No, just like that. Oh my god, you don't take it.
I always use my phone.
What's your name?
Her name's
Like
what?
this? Yeah, like that. I like this way.
Jay.
I don't know.
Lunch and meat. Josh. Josh.
I like that. We're trying to do turn around again.
Oh.
I know for a fact.
I feel like my fingers aren't long enough. I don't have very long fingers for a puppet. Okay.
It's like flop.
It makes me feel all right, so all right. Alright, so the first one I would suggest switching to sine and cosine. And same thing here. And both of these work out to be really nice single trig functions at the end. So these work out to be nice, like a very simplified answer for that.
Do we have school next week?
Yeah?
We don't, we have it off Thursday and.
No, we have Friday. We have school on Thursday.
Oh no, Christmas on Saturday.
Yeah, I think
You just look
The
at the
last day
board.
next week is Thursday.
You just look at the board. A bunch of bots.
I don't remember that one.
What a bunch of bots.
Oh, maybe that's
Mr. Taliban. Oh,
Don't worry, I was I had a little bit of
We'll get to it, Julie, don't worry.
We'll work on that next year.
no, I don't want to actually. I don't want to be added into this. No, Most of these are just switching to sine and cosine. They work pretty nicely. Okay, flip it over when you're ready.
Wait, what? Oh, I was writing that down.
I'm trying to give you clues. Most of these are all switched to sine and cosine, it seems like.
How come sometimes sine has an E?
I don't know.
Can you just tell us what's the six?
Just tell us the
what's
answers.
sine and cosine?
Yeah, I switched to sine and cosine there. And then FOIL. Do you know all your Christmas shopping done? I'm super close.
Oh,
Nothing's
yeah, but
wrapped
it's
yet.
You haven't wrapped anything yet?
I know.
And I'm really not myself now. I'm afraid my dogs are gonna try and unwrap the presents. Because they like try to hide under the Christmas tree.
Wait, where do you put the presents?
Under the Christmas tree.
No, right now.
Right now
It's
they're
in
like
Santa's sleigh.
Yeah, I'm asking her, not you.
they're like we have like a extra dresser down in the like
I'm gonna go
our,
steal now.
our
I'm gonna
storage
wrap it for
space
you.
and we
I
have
thought Santa gave you presents.
mm-hmm.
He does.
Yeah. the
Santa
parents-
can only bring one
The
gift.
parents,
so funny.
the parents store the gifts for Santa. Yeah.
Yeah.
You don't understand that. Like,
You really think you can
Get them delivered all at one night.
We have to be logical
He's
here.
magical.
Santa just gives, Santa slaps a sticker in the house and says, alright, you're good. You're good. Give them to the kids.
Santa Claus learns Santa flies.
Santa's like a teacher. He makes sure you did your homework.
Dum dum.
So it definitely doesn't fly?
I'm gonna warn you guys. This one is weird
You.
but easy.
So you're gonna write
I was gonna write weird.
What?
This is I don't know what to write. I almost took it off of here.
Let's take it off.
cross it.
Let's do
Alright, we'll just
Cross it up. Cross
Extra credit if you do it.
Like we do extra credit on homework.
I'll just cross it off. Wait, so that means we don't have to do it? What's this?
Your mom.
So yeah, you can skip it if you want.
Okay, yeah.
That was the first score.
Bro, we don't even have
Did you take
8.
8 off? I took 8 off intentionally. Is it on yours?
You're
No.
wrong.
Yeah.
If it was, I would have done it.
There's no steering left.
Yeah,
Oh,
God,
I
let's sit at that.
Is that other right here? So who flies?
Just use identities there.
You fly.
You're supposed to switch to sine and cosine, obviously.
Obviously.
Switch cosine. Use it. Obviously.
Really, switching to sine and cosine on most of these. Alright. For the most part.
Oh, take it.
One of those one.
It's a little scary than I like it.
Yeah, no.
What? Well, like,
So basically, this is what you want. I'm not done yet, though.
what?
Owen.
What?
Number 1, 2, 3, sign, you can't just cross off those signs.
I'm wondering if the other way worked, John. That was already cotangent, but
No?
No.
that's what I did.
Again,
So you just multiply the cross.
What'd you say to me?
I need to go down.
Wait,
Yes. Yes.
no.